Hello everyone and welcome to my channel Integration Ninjas. In today's video tutorial, we are going to deploy Spring Boot application to an AWS EC2 instance using Docker and GitHub Actions. In today's digital landscape, deploying applications efficiently and securely is a crucial aspect of modern software development. By combining the power of Spring Boot, Docker, AWS EC2, and the automation capabilities of GitHub Actions, we can streamline the process, ensuring scalability, reliability, and maintainability for our applications. Throughout this tutorial, you will learn step by step how to leverage these technologies to deploy your Spring Boot application to a live environment. Whether you are a seasoned developer looking to enhance your deployment skills or a newcomer seeking to learn the ropes of modern application deployment practices, this tutorial is designed to provide you with practical knowledge that you can apply to your projects. So let's dive in and embark on this journey to deploy your Spring Boot application with confidence and ease. If you are new to Docker as well, let me just explain in short that what is Docker with example. Think of Docker as a container service for your software. Just like shipping container hold all necessary piece of a software application like code, dependencies, and relevant settings. This container makes it easy to transport your software from one place to another, and it ensures the software runs the same way no matter where it is used. I have explained it really well in my previous video of deploying Node.js app to EC2. You can refer that as well. As part of this workflow, I have created a workflow chart, what we are going to perform. I have a Spring Boot 3 application which will be running on Java 17. The Spring Boot 3 minimum requirement is Java 17. So we are going to write a Dockerfile for our Spring Boot application, and a workflow we will create where we will create two jobs, build and deploy. As part of build job, which will be running on GitHub hosted runner, we are going to build the Docker image and will publish it to Docker Hub. Once that build job is successful, then in the next deploy job, which will be running on AWS instance, where we will register our repository self-hosted runner, GitHub self-hosted runner to AWS EC2. It will run on that instance. There we will be going to pull the Docker image from the Docker Hub and will run that Docker image as a container service on EC2 instance. So let's move to the hands-on practice. Okay, I have this Spring Boot example here. So I will create a branch, deploy to EC2. Okay, so this application is nothing, just we will just hit the endpoint and we'll get some result like this: Integration Ninjas, name and the email address of my username. This simple API, we can see the code, what we have done as part of this. You can move to controller package and see what is the code, which is this API, cat mapping API on the direct URL access. We're going to provide these details, name and email address as part of response. Okay, so first let me configure this, check out this branch. Okay, this is master branch. I will check out the branch and will pull the latest changes I have and will move to this deploy to EC2 branch. Okay, so let's start doing this. We delete this existing files. I will create a new Docker file for this applications. How we are going to do is we will just we are going to create a new Docker file. Here we will be defining the base image which we are going to build. So we are going to create our Docker image based on Java. So we are going to use a JDK. We will use Eclipse Temurin JDK. Okay. So we will use the 17 JDK Alpine here. So inside Docker, we will use this JDK to run our project as a Java. Okay. And now we'll define a work directory that will be /app. We will name it as inside container. We will have this directory. And now we are going to copy this jar file that we are going to build as part of this project, spring boot -example.jar, to the container. So this is inside target, then spring boot example.jar. We are going to give the same name in the container as well. And now we are going to expose the port 8080. Since our application is running on 8080 inside Docker container, we are going to expose this port. Now we will run this jar. How we can run? Simply java-jar. We can use java-jar and the file name, which is spring boot -example.jar. Okay. So this is our Docker file. And now we are going to write a workflow file. So we are going to write a new workflow file. We are going to name it as CICD, and where it will be triggered on event we need to define where it will be triggered. On push event it will be triggered, correct? And on which branch it will be triggered, we need to define that as well. We will define deploy to EC2 whenever we are going to commit and push anything to this branch. This job will be triggered and it will build and deploy to AWS EC2. For that, we'll write two jobs. Okay. One job is build job. Okay. Which will be running on the GitHub hosted runner, Ubuntu latest. Ubuntu latest is provided by GitHub. This is runner. It is free to use for a limit. In this image, we have pre-installed Java and Maven and Docker. So we don't need to install. We just need to configure the Java environment variable to Java 17. For that, we will configure the Java. It will not be downloaded. It will be cached. Okay. So first of all, we need this code to be present inside the GitHub hosted runner. For that, we will check out this code. Check out source, and we'll use the action which is provided by GitHub to check out the source code. Actions checkout version 3. All right. Now we will be configuring the Java. Okay. We'll name it as setup Java. For that, we will be using another action which is provided by GitHub. Action setup Java version 3 with distribution this and this. So we can reuse the same. Reuse the same. Okay. So for that, this is action /checkout. Not checkout. It will be setup -java @version 3, and with these variables, the distribution we need to provide, which will be Temurin, and Java -version. So these are basically the inputs accepted by this setup Java. These are the inputs. Now, what we are going to do is we are going to build our project. or install the dependencies. You can see build project. We will run this command to build our project, mvn clean install. Okay, so after doing this, we will log into the Docker Hub container to push the image. For that, we can write another step, log into Docker Hub. So for that, we will use this command docker login -u username and -p and password. Okay. So yeah, this is one thing. So username and password, how we are going to use, I'm not going to expose it here directly. We'll use secret variables. We can define secret variables in our repository settings. If you go to the settings, we will not expose it in our YAML file, but we will be able to access from the secret variables under security and secret variables. Click on actions. Under secrets, I have added this Docker username and password. This is easy. You can configure it like this. Click on new repository secret and click on test. Give some any test name and test value, and just click on add secret. That's it. Repository secret will be added like this. So how we are going to access this? Okay, we are going to access this like this: dollar and double curly braces and secrets dot the variable name. Okay, so we are going to do it same for the passwords. Secrets dot docker underscore password, which is my variable for password. All right, now what I'm going to do is I'm going to build the Docker image from my current code and will publish it to Docker Hub. For that, I'm going to use this command docker build -t and the image name. I'm giving image name as integration ninja / spring boot -example. Okay, which will be created from this directory. Okay, now I am going to publish this image to Docker Hub. For that, I will run this command docker push and the same image name integrations. Yeah, the typo mistakes. It happens generally with developers. Docker push integration ninjas and the latest tag of my image I am going to push. Okay, so this is one job. Now we are going to define another job, which will be the deploy job. Once this process will be finished, we'll create another job, deploy job. When this will be triggered, we will define this, that this needs build job to be processed first, then this will be triggered. Okay, so and where it will runs on, we need to define a runner here. I will be using a self-hosted runner here. I will register that runner on AWS EC2 instance. Okay, so for that, you can simply go to your AWS EC2 instance and you can click on connect, and simply if you click on connect, you will be able to access the terminal, AWS terminal. It depends on you can log in it via PuTTY or you can log in it from the SSH also from the terminal. Okay, now how will register the self-hosted runner? We are click on runners, action and runners, then click on new self-hosted runner and click on the Linux, because our machine is Linux, AWS Linux machine we are going to perform these steps. Okay, so Let's configure the runner, self-hosted runner. We have created a new directory, actions runner. There we will download this action binary. Okay. After that, we are going to extract the GitHub installer. After that, we are going to configure it. Okay. So let's configure this. Okay. Enter the name of the runner group. I'm having it as default. I'm giving a name to my runner AWS EC2 and giving the same label name AWS EC2, and the work folder I'm setting it as default. So if you see, the runner is configuration settings is successfully saved. After that, you need to run the runner, self-hosted runner. For that, you can just use this command run.sh. You can execute this script file. So it is showing connected to GitHub. Okay, we can see it here in our runners page, AWS-EC2. We will be using this runner. Now our repository will have and pipeline will have access to AWS EC2 instance. Okay, so there we can perform these steps, that we can pull the image from Docker Hub. Okay, and with this following command, docker pull, and I will use this image name with the latest image which is available. Okay, I am going to use this, and after that I will going to run it as container, run docker container. Okay, for that I will execute this command docker run -d -p. I will define the ports that I have used, 8080. I'm going to use to access this application. Now I will give this container a name, Spring Boot -example -container. This I will use. If it is already exist, I will remove, and then again, suppose if I am deploying again and again, so I will remove the existing one. So that's why I'm giving the name. Okay, and we'll use the image docker run and this image. So we can add one more step here, that if this already exists, since we will deploy frequently, sometimes after committing some changes, delete old container. Okay, so there we can run this command docker rm -f and Spring Boot example container. All right, so this is the workflow, complete workflow. Let's see how it goes. If any mistake is there, we will correct it. Okay, let's comment these changes. Oh, deploy to EC2. Now we are going to push this changes, and we'll see if this is working properly or not. You can see the event has been triggered, the build and the deploy job. Let's monitor this. This is in progress, build project, ambient clean install. Okay, there is some issue. The push refers to repository integration ninjas. Okay, there is some issue with this. Requested access to resource is denied. We can see to the Docker hub, and I'm going to log into Docker hub with my credentials and see. So this is the correct name we are going to use. We can correct it here if it is wrong. Okay, we can build this. This is my correct username. There is some typo in the username, so we can correct and reuse. Yeah, the username was incorrect. All right. So now we are going to run this. Now we can monitor this. So again, the build is in progress. This we need because we need to build the jar and create the jar, and that jar will be used while creating the image. Since this job is successful, there was a typo in the username. Now we can see, okay, the deploy job is also successful. Okay, great. So now let's see if we can access that our application or not. We will use the AWS instance IP address. Okay, and we have used the port 8080, so we'll try to access with that. Okay, this is not accessible because we need to enable the inbound rules to for this security group as well. For this EC2, we'll click on this security group and edit the inbound rules. Okay, and there I will add a rule which will be having the custom TCP and the port 8080, and I will give this range. Okay, I will give a custom range of this 000 and will save this rules, and now I will try to access this. Yes, you can see this is accessible now. This is how now if you commit every time, it will the code to that specific branch deploy to EC2 branch. You can give any branch name. You will be able to deploy every time once your changes will be deployed to that particular branch. This is how you can deploy your Spring Boot application to AWS EC2 instance by containerizing your application and deploy with the power of GitHub Actions. Please comment and let me know if you like my video, Please share and subscribe. If anything is needed, you just tell me. I will improve. And also, I will try to have to deployment approach on ECR and ECS in my upcoming videos. Thank you, everyone.